Hello there, this is the Math Dog. In this video, I continue my introduction to angles where I look at here the angle addition postulate. This could be a middle school video, it actually could be an early high school video as well. Before watching this video, please watch my video on the introduction to angles. So let's get started. So the angle addition postulate says I have a diagram here. I have an angle AXB, an angle AXC, an angle BXC. Remember angle BXA and angle. So let's write that. Remember that the vertex of the angle, which is X here, must be the center letter when you name it. So angle AXB, for example, is the same angle, and this means congruent. Congruent means the same here. Is the same as angle BXA. AXB and BXA are the same angle, just like BXC and CXB are the same angle. You can name them either way. You cannot call these angles, you have three angles here, so angle X is not a sufficient naming here because there's three angles that include X as its vertex. You have angle AXC, angle AXB, and angle CXB. So in my diagram, I'm saying if two angles AXB and angle CXB are adjacent, remember what adjacent means. It means they're basically next to each other. They share a common vertex and they share a common side right here, or arm. So these two angles share ray XB. Ray XB I've written like this. So if two angles, angle AXB and angle CXB, are adjacent next to each other, that means they share a common vertex and a common side, with common ray XB, that being the common side. Then it follows that the measure of angle AXB plus the measure of angle CXB equals the measure of angle AXC. So for example, if they're adjacent, let's say this is 40 degrees, let's say this is 35 degrees, then that would mean that that'd be 40 plus 35 is going to equal 75. So the measure of angle AXC is 75. Okay, so in this particular diagram, why does the measure of angle AXB, which angle AXB is this angle here, that's AXB. Why does the measure of angle AXB plus the measure of angle CXB, CXB is this angle, why does it not equal the measure of angle AXC? Well, the thing that's different here is that these angles overlap. So AXB and CXB overlap, and if you remember, for an adjacent angle, three things had to be true. So these angles are not adjacent. One, common vertex. Two, common side. So these two angles actually meet the first two criterion. They have a common vertex and they do actually share a common side XB. The problem is that there's an overlap here, and you can see that overlap. So if I use a paintbrush here, so here is AXB, that's the interior of that angle, then the other angle is CXB. There's a common, they overlap because of this blue that I'm shading right here. So this is not true because they overlap. So again, for adjacent angles, they have to have a common vertex, common side, and they cannot overlap. So this example does not fit the criteria for the angle addition postulate. Now it is true, though, that we could have written, I didn't ask this, the measure of angle AXC, which is this angle, plus the measure of angle BXC. That does equal the measure of angle AXB. Now that does meet the criteria for the angle addition postulate because you have adjacent angles here. AXC and BXC are adjacent. They share a common side XC and they share a common vertex X, and they do not overlap each other. So that's what I just did up there. So complete the statement. The measure of angle AXC, which again remembers the same as CXA, plus the measure of angle BXC, which is same as angle CXB, equals the measure of angle AXB. So this measure plus this measure equals the total measure there of angle AXB. Okay, let's do some examples now. So what I want you to do is I want you to copy the diagram on these. I'm going to give you some problems in a bit for you to do and then check them. So you want to mark up your diagram. So I say the measure, and this M means measure. And this is an abbreviation for angle. So measure angle AMT is 155 degrees. So that's 155 degrees. Okay, WMT is 28 degrees. So these are adjacent angles. So I want to find the measure here. So let's call that X. That's an unknown. So I know that by the angle addition postulate, X plus 28 has to equal 155. So solving for X, what I can do is I can subtract 28 from both sides. And I get X equals, well, 155 minus 28. Okay, I have to borrow there because I can't take 8 from 5 without getting negative. That becomes a 4. So I have 7, 2, it's 127 degrees. Now you don't have to use X there, you could just go 155 minus 28 is 127, but I'm trying to get you familiar with using an unknown. So X in this case will have a particular value, so this is going to be 127 degrees. Okay, in my next example, these are assumed to be straight angles here. Actually, I told you that. QHV is a straight angle. That means its measure is 180 degrees. Okay, so I'm not even going to put that on there. We should know that if it's a straight angle. The measure of angle THV is 88 degrees. Okay, and THM, which is this angle here, is 64 degrees. Okay, so now we should be able to answer my questions. So find the measure of angle MHV. That's 88 minus 64, which is 24 degrees. Now you could have called that X again, and you could have done it that way like I did in the previous problem. X plus 64 has to equal 88 by the angle addition postulate. Subtract 64 from both sides. Because what you do to one side in an equation, keep it balanced, you must do to the other side. So that's going to be X is 24. Now notice right here, those are vertical angles. They point at each other. So MHV here is again 24. I want you to find this angle XHV, but I know this is 24 degrees here because these are vertical angles here and here. They point at each other. Two intersecting lines form vertical angles. They point at each other. Well, we know this is 180 degrees because it's a straight angle. So if I call this Y, this unknown, which is measure of angle XHV, I know that 24 plus X has to equal 180. So I subtract 24 from both sides. So I get X is, again I have to borrow here, that becomes a 7, so that's 6, 5, it's 156 degrees. Now again, that's using the angle addition postulate, so you could also have gone 180 minus 24 is 156. Okay, so that's 156 degrees. Let's clean that up a little there. Okay, continuing. Alright, so I have a diagram here. I've given you some measures of angles. I want you to find the measure of angle BTC. So let's mark up the diagram. So the measure of angle ATD would be this angle here. That's 178 degrees. Measure of angle BTA, that's right here, is 25 degrees. So actually, well, we'll not keep going here. Okay, so the measure of angle DTC is 36 degrees. Okay, so we can apply a variation of the angle addition postulate, because you notice this angle here, angle ATB, is adjacent to angle BTC, which is adjacent to angle CTD. So I could call this angle BTC here, which I'm going to put in purple, I'll call that X. So I know that 25 degrees plus X degrees, which I don't know yet, plus 36 degrees has to equal 178. Combining like terms there, 25 and 36 is 61. So 61 plus X is 178. Now this is a one-step equation again, so I subtract to find X, I get rid of the 61, so I subtract 61 from both sides, and I get X is 107 degrees. So the measure angle BTC is 107 degrees. So this is a simple enough problem. You could have added 25 and 36 together just using arithmetic. That's 61, and then take 178 minus 61, which will give you the missing measure here of angle BTC, which again is, I wrote 107, I was wrong there, that should be 117. So let's fix that, excuse me. So the measure of angle BTC should be 117 degrees. Alright, I want you to stop the video and take the information I've given here and solve this practice problem. Draw the diagram. Take the time to draw the diagram and mark it, and then answer the questions. Or actually just one question here. Okay, let's look at this problem. So measure of angle MNQ, which is this angle here, is given as 149 degrees. QNS, which is this angle here, is 38 degrees. So I want to find the measure of angle MNS. I'll call this X. So I know by the angle addition postulate, X plus 38 equals 149. These are degrees. So to solve for X, I subtract. To undo addition, I use subtraction, the opposite operation. So X is equal to 100, well that's going to be 1, so 111 degrees. So the measure of angle MNS is 111 degrees. You could have just gone 149 minus 38, got it that way, but I'm trying to get you to see how to solve an equation, because that's something that's going to be coming up into the future as you advance in school. Alright, another practice problem. Stop the video. This one's got a little bit more stuff to do. So I'm going to say, I'm telling you right off the bat that angle ATV and TVM, and that is not written right. TVM is not an angle here, it should be V. Let's fix that. That should be angle VTM because the vertex is T. So there I got caught in naming an angle incorrectly. TVM is not what I want. I want VTM or MTV. Okay, so I'm telling you then, let's fix this also. That should be VT. Actually, that's right there. Let's fix that. That is okay. So again, these two angles here are complementary. The measure of angle VTM is 17 degrees, and then find those missing angle measures there. So stop. I'm stopping the video, or you're going to stop the video. You're going to solve for those unknown angles and then turn the video on and see how well you did. Okay, so let's mark this up. I know that if they're complementary, that means they equal 90 degrees. Notice these are adjacent angles, so that has to be a right angle there. That's 90 degrees. You know that VTM is 17 degrees. Therefore, this has to be 90. This is 17. by the angle addition postulate, if you called that x, you know that x plus 17 is 90. Subtract 17 from both sides, you get x is 73. So this is 73 degrees. And that is angle ATV, which is right here. So I'm going to put 73 degrees, I know that. So now angle, ask me what is angle ATK? Well, this is a straight angle here. So that's 180 degrees. If this is 90, that also has to be a right angle. That also has to be 90. So ATK is 90 degrees. It's a right angle. So then I ask you about KTX. Well, if this is 17 degrees, this has to be 17 degrees because these are vertical angles that point at each other. So that's 17 degrees. So KTX is 17 degrees. So then I'm asking you about XTM. Well, XTM is this angle right here. Again, that's this angle right here. So this is a straight angle again. That's 180 degrees. So this is 17. If I call this Y, I know that 17 plus Y is 180. So if I want to solve for Y, I need to get rid of 17 by subtracting it from both sides. So I have to borrow here. That's 7. 10 minus 7 is 3. 7 minus 1 is 6. So it's 163 degrees here. So XTM is 163 degrees. Okay, you could have just gone 180 minus 163. Yes, you could do it that way. And then XTP. Well, notice that XTP, let's choose a color I haven't used, green. Notice that these two angles point at each other. That's 73, so this has to be 73 degrees. And this concludes the problem and concludes the video. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you. Have a good day.